Hello everybody. Okay, so in today's video we'll be talking about a production function. So before we start with discussing what is a production function, the first thing that we need to know is what a function actually is. So I'm sure all of us know that, but let's have a quick recap of what we know. Think of a function as a machine. So let's say we have a machine and we put some inputs in it and we get some output in return. So why is it a function? Essentially, a function's job is to convert the inputs to outputs. Now, when we think of a mathematical function, let's say y equals fx. So this fx essentially is the mathematical representation of a function. This represents the machine that converts the input to output. So when we talk about this f is actually the machine, and the x is actually the input. So this is the input that we provide to the machine, and it pops out different values of y for those values of x. So let's say we are talking about a function y equals 2x. Let's look at this function first. If we talk about y equal to 2x, so if I just minimize this screen a bit, so if I talk about this function, if I talk about y equal to 2x, then my machine looks like this. And what happens is, if I pop numbers like 1, I get the output as 2. If I pop numbers like 3, I get the output as 6. So essentially, my function is essentially a machine which converts values of x to values of y. Now the question arises, does this function only work when it's given one input? Not necessarily. Let's say we have a function y equal to, or let's say instead of y, let's consider a bigger function. So let's say I have a output z, and that z is actually equal to x plus y. Let's take a simpler function. Let's take a simple function. So I'm talking about this function. Now, how will this function look like? This function will look like this. So we have a machine uh, in the form of the function. So this is the function that we are talking about. This machine, this function uses two inputs because we have an x and we have an y. So we pop one value of x and we pop one value of y, and we get one value of z in return. So let's change the color once. So if I have two values of input for this, let's say I take x equal to 1 and I take y equal to 2. So if I put x equal to 1 and y equal to 2, I get 1 plus 2, and they pop out the value 3. So I get z's value to be 3. Similarly, if I put, let's say, x equal to 3, y equal to 5. So that pops out the value 8. So essentially, it's as if a machine, and I input certain values of the function, and it pops out a number in return, in answer. Essentially, it's like a function essentially. Now, why do we need to know what is a function in order to understand a production function? Essentially, a production function behaves in a similar way when we talk about a machine. Essentially, what is production? Production essentially converts my inputs to outputs. That is what the function of production, that is what a production is all about. So let's suppose I am an inventor, or I'm a shopkeeper, and what I do is I sell, let's say I sell pencil boxes. So I have this commodity called a pencil box, and for every pencil box I need one pencil. So I need one pencil, and I need, let's say, one pen. I need one pen, and I need one, since I have a pencil, let's say I have one, I use one eraser as well. So let me just write that down. That is what I need to produce my pencil box. Let's say I also buy some pencil boxes from another stationery shop and I just resell them. So this is essentially what I need to produce my pencil box. Now, what will my production function look like? Essentially, my production function will again look like a machine. What I'll be doing is I'll be inputting values of pencil, pen, and eraser, and in return I'll get one value of one unit of pencil box. So I put one value of pencil. Let's call this P, since it's pencil. Let's call this N because we already have P standing for pencil, and let's call this E. So, and let's call this B because it's a pencil box. So essentially we put some value of P, we put some value of N, we put some value of E, and we get a value of B in return. Doesn't this remind us of a function, right? It looks like a function. We discussed about a function a few moments ago, and this pretty much looks like a function. So this production function, now why is it a production function now? Because I'm producing pencil boxes. So what will this production function now look like? If I just change the color, this production function, let's say it pops out the values of B because I'm producing pencil boxes. This will be a function of number of pencils that I have, number of pens that I have, and number of erasers that I have, right? For every value of, let's say, now let's look at the functional form of the production function. So every box that I have uses one pencil, one pen, and one eraser. So if I pop the values P equal to 1, N equal to 1, E equal to 1, I get B equal to 1. Let's say I buy from the stationery shop that I buy my raw materials from. Let's say I buy two pencils, two pens, two erasers. So I actually can make two pencil boxes out of that, right? I put one pencil, one pen, and one eraser in one box, and I put the second pencil, the second pen, and the second eraser in the second box. So this goes on. So if I have three pencils, three pens, and three erasers, I get three boxes. Now, what happens if I buy two pencils, one pen, and one eraser? Now what I can do is I can put the first pen, that is the only pen, and the other eraser and the only eraser in one box. But what do I do with the second pen? I do not have other inputs to create one pencil box, right? So what I can do is, even if I input two pencils, one pen, and one eraser, I still get one pencil box. So this is what my functional value looks like. This is what my function looks like. For these values of pens, pencils, and erasers, my output will be this. Similarly, let's say I put two pencils, two pens, one eraser. I still get one pencil box. If I put three pencils, three pens, and one eraser, I still get one pencil box. So let's look at this function closely. Let's look at this function closely. Look at this. If it's 211, my output is 1. If it's 221, my output is 1. If it's 331, my output is 1. Let's say if it's 5, 9, and still 1. So I have 5 pens, 9 pencils, and still 1 eraser. I can only make one pencil box, right? Can we represent this function? Can we represent B as minimum of P, N, and E? Can we represent this production function as minimum of P, N, and E? So whatever be the minimum value, let's say I have 6, and 3. So I have 6 pens, 6 pencils, and 3 erasers. I have 3 erasers, so I can actually produce 3 pencil boxes. I will be left over with 3 pencils and 3 pens, but I can still make 3 pencil boxes, right? So essentially, the minimum of the 3 quantities will be the number of pencil boxes that I produce. I will be left over with some raw materials, but I still will be able to produce some pencil boxes. So this function is actually the function that I'm considering for this production function. This production technique, this production mechanism that I'm talking about, this production function looks like this. This is called the minimum function. So I have B equals minimum of P, N, and E. Now, I have this production function, but does this work for all production functions? Does this work for all production possibilities, for all production techniques? Not necessarily. I can have other functions as well. So in today's video, what we have basically talked about is one possibility of production function. In fact, this sort of production function is something called the Leontief production function. Leontief production, let me just get that right. Leontief production function. It was discovered, or it was propounded by a person named Leontief, Vasily Leontief, and he essentially talked about this in extension to something called an input-output analysis, which we'll be talking about in our later videos. What he essentially said, that these production function, they have these special characteristics called fixed proportion. Fixed proportion production functions. Why is it fixed proportion production function? You see, if I am talking about the proportion of inputs that I am using in my production process, let's look at a different color. In this production function that we are discussing, the inputs are always in the proportion 1 is to 1 is to 1, right? If we have two pencils, three pens, and one eraser, it won't necessarily be an efficient production. I will be left over with certain raw materials. So my raw materials should be in the ratio 1 is to 1 is to 1. No matter what the other components are, I just need one of this, and one of this. So one of pen, one of pencil, one of pen, and one of eraser. This is a fixed production function. That is why it's called a fixed production function, fixed proportion production function. It works in fixed proportions. Similarly, you can have other production functions. Let's say you are selling jewelry, so you need two earrings and one necklace. So in that case, let's say if you are producing jewelry, that jewelry production function, that will be a function of in that case, what will happen is, let's say you have earrings, and let's say you have necklace. Now here I'm not talking about pairs, because I want to show you different types of production functions. So let's say I have two earrings and one necklace, so I'll be able to sell one set of jewelry. So if this is J, I can't actually wear only one. Well, it is a style now, but let's talk about the default settings. So let's say I have one piece of earring, so I can't wear that. So I need two pieces of earrings, one necklace, and that gives me one set. If I have three pieces of earrings and let's say one necklace, I can still make only one set. If I have four pairs of earrings and if I have one set, I can still make one set. If I have four pieces of earrings and two necklaces, so I have two earrings with one necklace and two earrings with one necklace, so I can have two jewelry sets. So essentially, this reminds me of the production function E by 2, or rather, let me just put the minimum function. So J this time will be minimum E by 2 comma n. Why is it E by 2 comma n? Look at this. If I take a different color, let's take red. If I'm taking 2 comma 1, I can't write minimum E by E comma n. Why can't I write minimum E comma n? Because if I take minimum E comma n, my output will be 1. This is fine. But if I take minimum 4 comma 2, what happens is I actually need two pairs of earrings, right? So that won't work if I have E comma n. I need to have E by 2 comma n. Let's think of an example. Essentially, what I want to show is, in this case, since I have fixed proportions of 2 is to 1, so I need my inputs to be in the ratio 2 is to 1, right? So in that case, I have 2 in the denominator for this and 1 in the denominator for this. So that is essentially what we talk about as the Leontief production function, or the fixed proportion production function. So this is just one possibility of production functions. There are different types of production functions. So we have constant returns to scale. We have different properties of production functions as well. If I talk about the types of production function, we can have Cobb-Douglas production function. We can have fixed proportion production function, the function that we discussed right now. We can have production functions for perfect complements, for perfect substitutes. Essentially, if I talk about this production function is actually a perfect complement production function. Why? Because I cannot have one pencil and one pen without an eraser. So these are complements, right? We need to use one with the other. So these are also called perfect complement production functions. Though perfect complements is some most often used in consumer theory, but even in production theory, it's still used. So essentially, this is a Leontief production function, fixed proportion production function, and it's one type of production function. And this is what production function is all about. This is just an introduction to production function. There's whole lot more to come. We'll be talking about the different curves, how it looks in graph. Actually, a production function can have two graphical representation. One is, if I'm talking about, let's say I'm talking about production functions which use two inputs. So let's say I have an input x and an input y. Then we can have graphs called isoquants, which essentially show how the inputs and the outputs are related to each other. Then we can actually have input output. So essentially, if x is my input, and in this case, let's say if f is my output, then we can actually relate input to output in the same diagram. So here essentially x and y are two inputs, and here x is the input and f is the output. We can have different graphs like the total product curve, we can have the marginal product curve, the average product curve, and we can relate that to the cost functions. But essentially, this is what production function is all about, and in our future videos we'll be talking more about them.